Okay, so today's topic is electricity, and which is what this course is all about. In this introductory course, we want to know what electricity is first, and to be very frank with you, nobody really has a total idea of what electricity really is. We have certain models that we use. One of them is the model that's most popular is that it's a movement of an electric charge. Okay, mainly in the case of electricity that we use in all of our circuits, it's a movement of the electrons that we say are negatively charged. Okay, they're negatively charged because we said it was negatively charged, and for every negative charge, there has to be a positive charge as well. Okay, so that we call a proton, or the nucleus itself that's full of protons. So the atom itself is composed of neutrons, protons, and electrons. Electrons are negative, protons are positive, but only electrons are the things that actually conduct. Okay, we can get an atom to conduct if we ionize it. So if we have an atom in a fluid that's ionized, okay, that can conduct because it's a charged particle and it can move. All right. So if we treat the, the definition of electricity as a moving charge, then there you go. We've got a model that seems to work quite well. It also works well when we speak about electromagnetism, because we found out that if you have a stream of electrons that are moving, all of a sudden you've created uh, a magnetic field, which we call electromagnetism. Right? We'll learn about that when we later on when we talk on AC circuits and motors and generators as well. But for now, let's talk about the parameters that define electricity. The first, of course, we want to talk about what is a charge. Charge is measured using coulombs. Okay, coulomb is the unit of measure for charges. Okay, when you have a bunch of charges all together that are negative, and you have another area that's full of positive charges, okay, then you've got what we call a potential difference. And that potential difference we call voltage. Voltage is an important parameter for electricity. It's what actually causes electricity to flow. Right? We in a circuit. Of course, the best definition of electricity is that it is a way of distributing energy from a high energy state to a low energy state. In other words, electricity uh, is the flow of energy from an abundance of energy to one of lower amount of energy. And normally in physics we say if it's a high energy, it's a positive state. If it's a low energy, it's a negative state. Okay, so it goes from a positive to a negative. So the flow in this case goes from positive to negative, whereas for electron flow, we have the flow is going from a negative to a positive, right? And I prefer the energy because, and most everybody does, because most of our instruments are built on the high voltage being a positive voltage and having a red probe or a red uh, attachment point, and the negative, or what we call a lower voltage position will be either a black probe or a black dial. Okay, so that is the energy flow model, right? But the actual flow of the energy is called current. Current is measured in units called amperes. Okay, and both voltage has a polarity, okay, a plus and a minus polarity. A current has a direction. Okay, the current, you can say, goes from positive to negative when you use the energy model, but it goes from negative to positive if you use the electron flow model. Okay, so current is, I like to use the energy model because later on we will talk about voltage drops. So there's a voltage that drops from a high voltage plus voltage to a lower minus voltage, which describes the energy model. All right. Okay. Then the next physical parameter that we need is power. Okay. We talk about energy, and power is just the way that energy is being distributed in time. So energy or power is energy per unit time, the flow of energy. Finally, we talk about resistance. If there's a flow, there's going to be a resistance to that flow. Okay, and tomorrow we'll talk about resistors that add that resistance that's measured in ohms. Now, this course is about DC currents, DC voltages. Okay, but after this and the next course, we will talk about AC currents, alternating currents, which run in both directions. First one way and then back the other way. First back, forward and back, okay? That's an alternating current. That's what the current that and the voltage that comes out of your wall sockets, all right? We'll talk about that. But the rules that are good for DC may also apply to AC as well, okay? But so today we will, the presentation is all about what I just went over, maybe in a little bit more detail. And if you have any questions about it, don't hesitate to call me. Do the homework. The homeworks are always on the last pages of the graphics document. And then we'll go over them tomorrow. So carry on.